In the summer of 1974, the CIA pulled off the most audacious theft in Cold War history. They built a ship longer than 2 football fields, assembled a crew of over 180 people, and told the world they were mining for minerals on the ocean floor. But their real mission? To steal a sunken Soviet nuclear submarine from 3 miles beneath the Pacific Ocean, right under the noses of Soviet intelligence. This wasn't just espionage. This was engineering warfare at a scale never before attempted. The ship was called the Hughes Glomar Explorer, and what it accomplished changed naval intelligence forever. This is the story of Project Azorian, the impossible mission that remained classified for decades, and the technical marvel that made it all possible. The year was 1968. The Cold War was at its peak. The United States and the Soviet Union were locked in a nuclear standoff that kept the entire world on edge. Every piece of intelligence mattered. Every advantage could shift the balance of power. And on March 8th of that year, something happened in the Pacific Ocean that would set in motion one of the most remarkable intelligence operations in American history. A Soviet Gulf II-class ballistic missile submarine designated K-129 by the Soviets was on routine patrol about 1,560 miles northwest of Hawaii. The submarine carried 3 nuclear-tipped ballistic missiles. It had a crew of 98 men, and on that March day, it vanished. No distress signal, no warning. The submarine simply disappeared beneath the waves, taking all of its secrets with it. The Soviet Navy launched a massive search operation, scouring thousands of square miles of ocean, but they never found it. What they didn't know was that the United States Navy had been listening. The U.S. had an extensive network of underwater listening posts scattered across the Pacific Ocean. These installations were part of a top-secret system called SOSUS, the Sound Surveillance System. SOSUS was designed to track Soviet submarines by detecting the sounds they made underwater. The hydrophones were so sensitive, they could pick up the sound of a submarine's propeller from hundreds of miles away. And on March 8, 1968, SOSUS picked up something unusual. A brief, sharp acoustic event, an implosion. Something had catastrophically failed deep in the Pacific. U.S. Navy intelligence officers went to work. They analyzed the acoustic data, they calculated the location, they cross-referenced it with known Soviet patrol areas, and they realized something extraordinary. They knew approximately where the Soviet submarine had gone down, and the Soviets didn't. This was an intelligence opportunity unlike any other. If the United States could locate the wreck and retrieve it, they could gain access to Soviet nuclear weapons technology, their cryptographic codes, and their naval communication systems. It would be an intelligence goldmine. But there was a problem, a massive problem. The submarine was lying on the ocean floor at a depth of approximately 16,500 feet, more than 3 miles down. At that depth, the pressure is over 7,000 pounds per square inch. That's enough to crush a car into a small cube. In 1968, no salvage technology existed that could recover something as large as a submarine from that depth. The deepest salvage operation ever conducted had been less than half that depth. What the Navy was considering was technically impossible. But this was the Cold War, and impossible was just another engineering challenge. The Office of Naval Intelligence briefed the CIA on the discovery. The CIA saw the potential immediately. This wasn't just about salvaging a submarine. This was about gaining a decisive advantage in the most important conflict of the 20th century. If it could be done, it had to be done. And so, in the strictest secrecy, Project Azorian was born. The first challenge was finding the exact location of the wreck. The acoustic data from SOSUS gave them a general area, but the Pacific Ocean is vast. They needed to search approximately 1,200 square miles of ocean floor. To do this, the Navy deployed a specially modified submarine called the USS Halibut. The Halibut was equipped with a towed camera system that could photograph the ocean floor at extreme depths. For weeks, the Halibut crisscrossed the search area, its cameras capturing image after image of the barren seafloor. Then, in August 1968, they found it. The cameras revealed the broken hull of K-129 lying in pieces on the bottom. The submarine had broken apart when it hit the ocean floor. The forward section, containing the nuclear missiles and the command compartment, was relatively intact. The rest of the submarine was scattered across the seafloor. Navy analysts studied the photographs intensely. They could see the conning tower. They could make out hatches and equipment. And they knew that inside that wreck were secrets that could change the strategic balance of the Cold War. Now came the hard part. How do you lift something that weighs thousands of tons from 3 miles underwater? The Navy's initial analysis was blunt. With current technology, it couldn't be done. The pressures were too great, the distances too vast, the engineering challenges too complex. But the CIA wasn't ready to give up. They brought in some of the brightest engineering minds in America. They consulted with deep-sea oil drilling companies. They talked to submarine designers. They explored every possible approach. Several ideas were proposed. One suggestion was to somehow attach flotation devices to the submarine and bring it to the surface. Another was to cut it into pieces and retrieve them separately. But each approach had fatal flaws. The submarine was too deep, too heavy, too fragile after 6 years on the ocean floor. Then one engineer proposed something radical. What if they didn't go down to the submarine? What if they built a giant claw that could reach down, grab the entire forward section, and lift it up? It sounded like science fiction, but the more they analyzed it, the more feasible it seemed. The concept was elegant in its simplicity, but staggering in its complexity. They would build a massive ship with a derrick tower that extended down through a hole in the center of the hull. Suspended from this derrick would be an enormous grappling device, a claw that could open and close. This claw would be lowered on a string of connected steel pipe segments, each one locked to the next, creating a pipe string that extended 3 miles to the ocean floor. Once the claw reached the submarine, it would close around the hull, and the pipe string would lift the entire mass back to the surface. The CIA gave the project the codename Jennifer, and later it would become known as Project Azorian. They estimated the cost at approximately $500 million, an astronomical sum in 1970s money. That's equivalent to well over $3 billion today. But the potential intelligence value justified the expense. The project was approved at the highest levels of government. President Nixon himself was briefed. The operation had a green light. Now, the CIA faced another challenge. How do you build a ship unlike anything that had ever existed, employ hundreds of people, and conduct operations in international waters without the Soviets figuring out what you're doing? You need a cover story, and it had to be convincing. This is where one of the most colorful figures in American business entered the picture: Howard Hughes. The eccentric billionaire industrialist had already made fortunes in aviation, movies, and defense contracting. He was reclusive, unpredictable, and perfect for what the CIA needed. The CIA approached Hughes Tool Company with a proposition. They would build the recovery ship under the cover of a commercial deep-sea mining operation. Hughes's company would be the public face of the project. The story would be that Hughes was developing technology to mine manganese nodules from the ocean floor. These nodules, potato-sized lumps of minerals, actually do exist on the deep ocean floor and contain valuable metals. The mining story was plausible enough that it wouldn't immediately raise suspicions. Hughes agreed to the arrangement, and the CIA funneled funding through his company. The ship would be called the Hughes Glomar Explorer. Construction began at the Sun Shipbuilding and Dry Dock Company in Chester, Pennsylvania in 1970. From the very start, this was no ordinary ship. The Glomar Explorer was 619 feet long with a beam of 116 feet. It displaced over 50,000 tons. But the most unusual feature was the opening in the center of the ship called the moon pool. This opening was 199 feet long and 74 feet wide. It was through this moon pool that the entire salvage operation would be conducted. Rising above the deck was a massive derrick tower, standing 253 feet tall. This tower housed the machinery that would raise and lower the pipe string. The pipe string itself was an engineering marvel. Each section of pipe was 60 feet long and made of high-strength steel. The pipes had to be strong enough to handle the immense loads, but light enough that the system could actually lift the submarine. The total weight of the pipe string when fully extended was over 7 million pounds. That's 3,500 tons of steel pipe hanging in tension over 3 miles of ocean. But the most critical component was the capture vehicle, the claw that would actually grab the submarine. This device was given its own code name, Clementine. The CIA contracted with Lockheed to design and build Clementine at their facility in Redwood City, California. Clementine was a feat of engineering that pushed the boundaries of what was possible with 1970s technology. The capture vehicle was essentially a massive rectangular frame, 179 feet long and 35 feet wide. It weighed approximately 1,800 tons. From this frame extended 8 giant steel tines, like the fingers of a hand. These tines were designed to be lowered around the submarine hull, then hydraulically closed underneath it, creating a cradle. But Clementine wasn't just a claw. It was a sophisticated underwater vehicle. It had its own propulsion system with thrusters that could position it precisely over the target. It had a complex hydraulic system to operate the tines. It had cameras and lights, so operators on the surface could see what they were doing. And all of this had to work reliably at a depth where the pressure would crush any flaw in design. The capture vehicle also incorporated a feature that was crucial to the mission's success. Once Clementine grabbed the submarine and began lifting it, the submarine would be drawn up into a covered chamber within the capture vehicle called the gimbal. This gimbal would surround the submarine hull, hiding it from view. This was essential because once the Glomar Explorer began its recovery operation, Soviet surveillance ships would almost certainly appear to observe what was happening. The gimbal meant that even if the Soviets were watching, they wouldn't be able to see what had been recovered. While the ship was under construction, the CIA was assembling a crew. This presented unique challenges. They needed experienced sailors and deep-sea drilling experts, but they couldn't tell most of them what the real mission was. The cover story about mining manganese nodules had to be maintained. Most of the crew genuinely believed they were working on a mining operation. Only a small group of CIA officers and senior crew members knew the truth. This operational security was maintained through careful compartmentalization. People knew only what they needed to know for their specific jobs. The crew also had to sign extensive non-disclosure agreements. These weren't ordinary NDAs. These were backed by the full weight of national security law. Anyone who revealed the true nature of the mission could face serious legal consequences. The CIA emphasized that lives could be at stake if the Soviets discovered what was really happening. This wasn't an exaggeration. If the Soviets realized the United States was attempting to steal one of their submarines, the international incident could escalate unpredictably. As construction continued, the CIA faced another problem. The Soviets were watching. Soviet intelligence had noticed Hughes Tool Company's sudden interest in deep-sea mining. They had observed the unusual ship being built. They began asking questions, but the cover story held. Deep-sea mining was a legitimate emerging industry. Several other companies were exploring similar technology. The CIA had even published papers about manganese nodule mining to add credibility. The Soviets remained suspicious, but couldn't prove anything. By 1973, the Glomar Explorer was ready for sea trials. The ship was equipped with a dynamic positioning system, one of the most advanced ever built. This system used multiple thrusters and sophisticated computers to keep the ship stationary over a specific point on the ocean floor, even in rough seas. This was crucial because the pipe string couldn't tolerate the ship drifting. If the ship moved while the pipe was extended, the lateral forces could snap the entire pipe string. The positioning system had to keep the ship within a few feet of its target position for days at a time. The ship also had sophisticated navigation equipment, powerful winches and cranes, extensive workshops and storage areas, and accommodations for a crew of over 180 people. There were laboratories where recovered materials could be analyzed. There were secure communication systems for encrypted messages to CIA headquarters. The Glomar Explorer was essentially a floating intelligence facility disguised as a mining ship. Every system had been designed with the mission in mind. Clementine, the capture vehicle, was transported from California to the recovery site aboard a submersible barge called the HMB-1. This barge was specially designed to submerge enough that Clementine could be floated into position, then raised again for transport. The barge was necessary because Clementine was too large and too secret to transport by conventional means. Moving these massive pieces of equipment across the Pacific without revealing their true purpose required elaborate planning and coordination. In June 1974, the Glomar Explorer departed from Long Beach, California, officially bound for a mining site near Hawaii. The crew included merchant mariners, engineers, technicians, and a contingent of CIA operatives. Soviet intelligence was aware of the departure. They noted the ship's course, but they still believed this was a mining operation. The cover story had worked. The Glomar Explorer sailed west, apparently heading for a mineral-rich area of the Pacific. But once out of sight of land, the ship changed course. Its real destination was approximately 1,560 miles northwest of Hawaii, to a specific set of coordinates where K-129 lay in pieces on the ocean floor. When the Glomar Explorer arrived at the site, the crew began the most delicate phase of the operation. First, they had to position the ship exactly over the target. Using their navigation systems and sonar, they located the wreck site. The dynamic positioning system was activated, and the ship began holding station. Then came the moment of truth. They began lowering the pipe string. Section by section, the steel pipes were added. Each 60-foot section was lifted by crane, positioned over the previous section, and locked into place. The process was slow and painstaking. Any error could be catastrophic. As the pipe string descended, Clementine hung at the end, sinking deeper into the black water. At 200 feet, sunlight disappears. At 3,000 feet, the pressure is over 1,300 pounds per square inch. At 16,000 feet, where K-129 lay, the environment is completely hostile to human life. The temperature is just above freezing, the darkness is absolute, and the pressure would kill a person instantly. But Clementine was designed for this. As it descended, its systems were monitored constantly from the control room aboard the ship. Every sensor reading was analyzed. Every camera feed was watched. After more than 24 hours of lowering pipe, Clementine reached the ocean floor. The cameras activated, and the crew got their first real-time view of the target. The submarine wreck was lying at an angle, partially buried in sediment. Rust and marine growth covered the hull. But the structure was recognizable. The conning tower stood out clearly. The missile tubes were visible. This was definitely K-129. Now came the most difficult part. They had to position Clementine precisely over the submarine, then lower the tines to cradle the hull. The positioning process took hours. Using Clementine's thrusters, operators maneuvered the capture vehicle back and forth, adjusting its position by feet, then inches. The cameras gave them visual reference, but operating by remote control from 3 miles away with several minutes of lag time was extraordinarily challenging. Finally, they had Clementine positioned correctly. The command was given to begin closing the tines. Hydraulic systems activated. Slowly, the massive steel fingers began to move, sliding underneath the submarine hull. Then something went wrong. As the tines closed, they encountered unexpected resistance. Part of the submarine hull was more deteriorated than the photographs had suggested. 6 years on the ocean floor had weakened the structure. The weight and pressure of the tines began to break apart sections of the hull. Operators watched in horror as pieces of the submarine began to break away. They had to make a decision. Do they abort and lose everything? Or do they continue and hope enough of the submarine remained intact to make the mission worthwhile? The decision was made to continue. The tines fully closed, gripping what remained of the forward section. They began to lift. The pipe string took the load, and slowly, incredibly, the captured section began to rise from the ocean floor. Tons of submarine, held by tons of steel claw, suspended on tons of pipe, began the 3-mile journey to the surface. The recovery process took several days. The pipe string couldn't be raised quickly. The stresses were too great. Each section had to be carefully monitored as the load gradually decreased with the reduction in water pressure. But as the captured section rose through the water column, the deteriorated portions of the submarine hull continued to fail. Welds that had weakened over 6 years underwater gave way under the stress. Structural members that had corroded finally broke. About a third of the way through the recovery, a major structural failure occurred. Approximately 2/3 of the captured section broke away and fell back to the ocean floor. This included most of the missile compartment and a large portion of the crew spaces. The crew aboard the Glomar Explorer could only watch helplessly as years of planning and millions of dollars worth of intelligence fell back into the abyss. But they still had something. About 38 feet of the submarine's forward section remained in Clementine's grasp. This included part of the command and control compartment and the forward torpedo room. As the recovery continued, another problem emerged. Soviet ships had appeared on the horizon. Soviet naval intelligence had finally become suspicious of the Glomar Explorer's activities. They had dispatched surveillance vessels to observe. The Soviet ships moved close enough to watch the Glomar Explorer, but didn't interfere. This was international waters. The American ship had every right to be there, but the Soviet presence meant the mission was now operating under hostile observation. This is where the design of Clementine proved its worth. As the capture vehicle was drawn up into the moon pool, the gimbal closed around the submarine section, completely concealing it. From the Soviet ship's perspective, the Glomar Explorer had lowered something down and raised something back up, but they couldn't see what. The cover story about mining still held. The Soviet observers likely suspected something unusual was happening, but they had no proof. They couldn't see the prize that was now hidden inside the American ship. Once Clementine was fully recovered and secured inside the moon pool, the Glomar Explorer maintained its position for several more days, conducting what appeared to be additional mining operations. This was misdirection. The CIA wanted the Soviets to believe this was just another day of mineral sampling. Finally, the ship departed the site, apparently heading back toward Hawaii. But once again, once out of sight, the ship changed course. It headed for a secure location where the submarine section could be properly examined. What the CIA found inside that section of K-129 was both valuable and sobering. They recovered 2 nuclear torpedoes. These gave American scientists detailed information about Soviet nuclear weapons design. They found cryptographic equipment and code books, though some had been damaged by seawater. These provided insights into Soviet naval communications. They recovered the bodies of 6 Soviet sailors.
The CIA treated these remains with respect, conducting a burial at sea with full military honors. This ceremony was filmed, and the footage would later be shared with Russia after the end of the Cold War. But they didn't recover what they most wanted. The nuclear missiles and their guidance systems had been in the section that broke away and fell back to the ocean floor. The submarine's main communications equipment was also lost. So was the nuclear reactor. The CIA had recovered perhaps 20% of what they had hoped for. Was the mission a success or a failure? Intelligence analysts debated this question. On one hand, they had gained valuable information about Soviet weapons technology. On the other hand, they had spent over $500 million and recovered only a fraction of the target. More importantly, could they keep it secret? The CIA knew that the longer the mission remained classified, the more valuable the intelligence would be. If the Soviets knew exactly what had been recovered, they would change their codes, modify their weapons designs, and update their procedures. The intelligence value would evaporate, so a massive classification effort began. Everyone involved in the mission was reminded of their non-disclosure obligations. Documents were secured. The Glomar Explorer itself became a classified asset.
For a while, the secret held. The Glomar Explorer continued to operate under its mining cover story. The CIA even considered a second mission to recover the rest of the submarine. But in 1975, everything changed. A break-in occurred at the offices of a company associated with Howard Hughes. Thieves stole documents, and some of those documents mentioned Project Jennifer. Investigative journalists began asking questions. The story was too big to stay hidden. In March 1975, the Los Angeles Times was preparing to publish an article about Project Jennifer. The CIA contacted the newspaper and requested that they not publish on national security grounds, but other newspapers got wind of it. The Times agreed to hold the story temporarily. The New York Times published a story about the mission on March 19, 1975. The secret was out. Within days, the media was filled with stories about the CIA's submarine theft. The Soviets officially protested, calling it piracy. The international incident that the CIA had hoped to avoid was now front-page news. The CIA took an unusual step. They neither confirmed nor denied the details of the mission. When journalists filed Freedom of Information Act requests for documents about Project Jennifer, the CIA responded with a now famous phrase: "We can neither confirm nor deny the existence of the information requested." This phrase entered the English language and is now commonly known as the Glomar response. It's still used today by government agencies when they don't want to reveal whether certain information exists. The story of Project Azorian became one of the most famous intelligence operations of the Cold War. Books were written, documentaries were made, engineers studied the technical achievements. The Glomar Explorer had proven that with enough ingenuity and resources, even the impossible could be achieved. The ship itself continued to operate in various capacities for years after the mission. It was eventually sold to private industry and used for actual deep-sea drilling operations. Clementine, the capture vehicle, met a different fate. After being recovered aboard the HMB-1 barge, it was stored in a secure facility. It was eventually cut up for scrap. The CIA couldn't risk the technology falling into foreign hands, and maintaining it was expensive with no planned future use. The technology developed for Project Azorian, however, had lasting impact. The deep-sea handling systems, the dynamic positioning technology, and the heavy lift techniques pioneered by the program influenced the offshore oil industry for decades. From a technical perspective, Project Azorian represented achievements in multiple engineering disciplines. The pipe string handling system could manage loads and stresses that had never been attempted before. The dynamic positioning system kept a 50,000-ton ship stationary in open ocean with unprecedented precision. The control systems for remotely operating Clementine at extreme depths pushed the boundaries of 1970s computer and hydraulic technology. And the entire operation was conducted in a way that maintained plausible deniability until long after the mission was completed. The intelligence value of what was recovered remains partially classified even today. The CIA has released some information about the mission through declassification reviews, but certain details about what was learned from the recovered submarine section are still secret. This suggests that even 50 years later, some of the intelligence gathered retains value. What is known is that the cryptographic materials helped the United States understand Soviet naval communication procedures. The nuclear torpedoes provided insights into Soviet weapons miniaturization techniques, and the analysis of the submarine's construction revealed information about Soviet metallurgy and manufacturing capabilities. But perhaps the greatest value of Project Azorian wasn't the specific intelligence recovered. It was the demonstration of capability.
The mission showed that the United States had the technical sophistication, the operational security, and the determination to conduct operations that seemed impossible. It showed that even the ocean floor, 3 miles down in international waters, wasn't beyond American reach. This had a deterrent effect. Soviet military planners had to consider that even their most secure secrets, even vessels that had sunk in the deepest ocean, might not be safe from American intelligence operations. The mission also revealed the lengths to which the CIA would go during the Cold War. $500 million. A ship built specifically for a single operation. A cover story elaborate enough to fool Soviet intelligence for years. Hundreds of people maintaining operational security, all for one submarine. This level of commitment to intelligence gathering helped define the Cold War era. It was a time when superpowers engaged in a shadow war, where victories were measured in secrets stolen and technologies acquired. The idea of building a giant claw to grab a submarine from 3 miles underwater sounds like a James Bond movie plot. Looking back from today's perspective, Project Azorian seems almost fantastical, but it really happened. Real engineers solved real problems. Real sailors operated real equipment under real pressure, and they succeeded, even if not completely, in one of the most audacious intelligence operations ever conducted. The technical documentation from the project, what has been declassified, runs to thousands of pages. It details every system, every calculation, every design decision. The project required advances in multiple fields. Material science had to develop new steel alloys that could handle the stresses. Computer science had to create control systems that could manage the complex operations. Mechanical engineering had to design pipe connections that could be assembled and disassembled hundreds of times without failure. Naval architecture had to create a ship unlike anything that had existed before. And all of this had to be done in secret, with compartmentalized teams who often didn't know what the other teams were working on. The men who served aboard the Glomar Explorer during the mission were bound by their non-disclosure agreements for decades. Many took their detailed knowledge of the operation to their graves. Only after major declassifications in the 2010s could some of them finally talk openly about what they had experienced. Their stories reveal the day-to-day reality of the mission, the tension when something went wrong, the exhaustion from working 12-hour shifts for weeks, the strange feeling of conducting a covert operation while Soviet ships watched from a few hundred yards away. These men weren't spies in the traditional sense. Most were merchant mariners and engineers doing a job, but they were part of one of the most significant intelligence operations of their time. They helped recover pieces of a Soviet submarine that provided insights into America's primary adversary during the Cold War. And they did it with a level of professionalism and operational security that kept the mission secret even when everything seemed to be falling apart around them. When pieces of the submarine broke away during recovery, they adapted. When Soviet ships appeared, they continued with the mission. When the media exposed the operation, they maintained their silence about the details.
The Soviet Union's reaction to the exposure of Project Azorian was officially one of outrage. They condemned the operation as a violation of international law. They claimed the United States had stolen their property. But privately, Soviet naval intelligence was probably more concerned with figuring out exactly what had been recovered and what secrets had been compromised. The fact that the CIA wouldn't confirm the mission's details made this assessment difficult. Did the Americans have the code books? Did they recover the nuclear missiles? The uncertainty forced the Soviets to assume the worst and update their security procedures accordingly. One of the often overlooked aspects of Project Azorian is the environmental challenge. The Glomar Explorer conducted heavy industrial operations in the middle of the ocean for weeks. The ship had to be self-sufficient for extended periods. It needed power generation, water treatment, waste management, and supplies for over 180 people. The ship was essentially a floating factory operating in one of the most hostile environments on Earth. Ocean storms could kick up waves large enough to damage the ship. The dynamic positioning system had to work perfectly in all conditions. A failure at the wrong moment could have been catastrophic. The ocean at 16,500 feet depth is a completely alien environment. No light penetrates. The temperature hovers just above freezing year-round. The pressure is equivalent to having a large elephant standing on every square inch of surface. Marine life at that depth has adapted to these conditions, but human technology struggles. Every seal, every joint, every piece of equipment had to be designed to withstand pressures that would instantly destroy ordinary machinery. The cameras and lights on Clementine were protected by thick glass ports. The hydraulic systems used special fluids that wouldn't freeze or become too viscous in the cold. The engineering team also had to account for the properties of the steel pipe string. Steel changes its properties under tension. A pipe that might be perfectly strong on the surface could fail under the combined stresses of tension, pressure, and cold at depth. The pipe string for Project Azorian was engineered with these factors in mind. Each connection point was designed to handle not just vertical loads but also bending moments. The entire string had to act as a single flexible column capable of lifting thousands of tons while remaining stable. When historians analyze Project Azorian, they often focus on whether the mission achieved its goals. The answer is complicated. Yes, the CIA recovered part of the submarine. Yes, they gained valuable intelligence. But no, they didn't recover the most important sections. And yes, the mission was eventually exposed, limiting the intelligence value. So was it worth $500 million? From a purely cost-benefit perspective, probably not. From a demonstration of American technical capability, absolutely. From a Cold War strategic perspective, it sent a powerful message. The legacy of Project Azorian extends beyond the Cold War. The techniques developed for the mission influenced how modern navies think about submarine operations. If something sinks, can it be recovered? What secrets are truly safe? The mission showed that depth alone wasn't enough to protect sensitive materials. This influenced how submarine crews are trained to handle classified materials. It affected the design of scuttling procedures for submarines in distress. If the Americans could recover a submarine from 3 miles down, what else could they do? The mission also influenced international maritime law. The question of whether the United States had the right to salvage a Soviet submarine in international waters sparked legal debates. Was the submarine still Soviet property even after it sank? Did the crew's deaths and the submarine's destruction change its legal status? These questions didn't have clear answers. The law of the sea evolved partly in response to incidents like Project Azorian. Nations became more explicit about their claims to sunken vessels. For the families of the Soviet sailors who died on K-129, Project Azorian was a bittersweet revelation. For decades, they didn't know what had happened to their loved ones. The Soviet government told them the submarine was lost at sea, but gave few details. When the mission became public, and especially when the CIA released footage of the burial at sea in the early 2000s, families finally had some closure. The CIA's decision to conduct a proper military burial showed a level of respect that transcended Cold War hostilities. These were sailors who died doing their duty, and they deserved honor regardless of which flag they served. Today, the wreck site of K-129 remains on the ocean floor. The sections that broke away during Project Azorian are still there, slowly being covered by sediment. The site is essentially a grave site for most of the submarine's crew. Russian officials have discussed possible memorial missions to the site, though the depth makes any operation difficult. The ocean has reclaimed the submarine, and the Cold War that made it a target is long over. But the story of how the United States tried to steal it remains one of the most fascinating chapters in intelligence history. The men who designed and built the Glomar Explorer and Clementine created something that had never existed before and may never be created again. The ship was purpose-built for a single mission. Once that mission was over, there was no other use that fully utilized its unique capabilities. It was like building a spaceship to visit a specific asteroid once. The technology developed for the mission found applications elsewhere, but the complete system was so specialized that it represented a unique moment in engineering history. Modern deep-sea recovery operations use descendants of the technology pioneered by Project Azorian. When Air France Flight 447 crashed into the Atlantic Ocean in 2009, the technology used to locate and recover the wreckage drew on techniques developed for missions like Project Azorian. When submarines or ships need to conduct operations at extreme depths, they use positioning systems and remotely operated vehicles that evolved from the same principles. The oil and gas industry's ability to drill and operate in deep water owes a debt to the engineering breakthroughs made during the mission. What makes Project Azorian particularly remarkable is that it succeeded at all. There were so many points where the mission could have failed. The submarine could have been impossible to locate. The Glomar Explorer could have had mechanical failures. The pipe string could have snapped. Clementine could have failed to grip the submarine. The Soviets could have figured out what was happening and interfered. Weather could have shut down operations. Any of dozens of technical systems could have malfunctioned at the wrong moment. But despite all these potential failure points, the mission recovered something. The human element of the mission deserves recognition too. The crew members who spent months at sea on the Glomar Explorer were away from their families, unable to talk about what they were really doing. The engineers who designed the systems had to work within strict security compartments, often unable to consult with colleagues who might have had useful insights. The CIA officers who planned the mission had to anticipate problems they had never encountered before.
Project Azorian represents a specific moment in history when the Cold War drove nations to extraordinary lengths, and everyone involved had to maintain absolute secrecy, knowing that one careless word could compromise years of work. Today, such a mission would be different. Satellite surveillance is more sophisticated, computer technology is far more advanced, but the ocean hasn't changed. It's still dark, cold, and hostile at 3 miles depth. It still crushes anything that isn't designed perfectly, and lifting thousands of tons from that depth is still an enormous engineering challenge. If a similar mission were attempted today, it would use different technology, but it would face many of the same fundamental problems. The story of Project Azorian is ultimately a story about human ambition and ingenuity. When faced with a task that seemed impossible, a group of engineers, sailors, and intelligence officers found a way to make it happen. They didn't succeed completely, but they succeeded enough to prove that even the most audacious plans can work if enough expertise, resources, and determination are applied. In the shadow war of the Cold War, where victories were measured in intelligence gathered and secrets kept, Project Azorian stands as one of the most remarkable operations ever conducted. It was the mission that tried to steal a submarine from the bottom of the ocean, and against all odds, it partly succeeded. That success changed naval intelligence forever and left a legacy that continues to influence deep-sea operations to this day.